The first one of the Live and Cure project applications is assessing the local scale surface temperature dynamics. Surface temperature is one of the most important parameters in the physical processes of urban surface energy and water balance, as well as the land-atmosphere exchange, and it constitutes an essential information source for their understanding and monitoring. In Cure, Application 1 provides time series maps at local scale, that is 100-meter spatial resolution of the urban land surface temperature at the time of the Copernicus Sentinel-3 satellite, that is 2 to 4 times per day, both for daytime and nighttime. The application products are already used within Cure applications for monitoring the urban heat emissions and the heat storage and assessing the surface urban heat island and the urban thermal comfort. Assessing the local scale surface temperature dynamics helps in understanding the thermal behavior of cities, and therefore planning offices can use this kind of information for their heat mitigation and adaptation strategies, while the monitoring capability may provide practical evidence for assessing the performance of planning interventions. Application 1 operates for all cities considered in Cure, and it is also transferable to cities worldwide, given that detailed land cover information is available. For the method itself, the Sentinel-3 mission allows the estimation of surface temperature with a spatial resolution of 1 kilometer at least twice per day. While this is a great source of information for cities from space in terms of revisit, the 1 kilometer spatial resolution does not allow discriminating between different temperatures of the urban objects. This spatial temporal resolution trade-off is common to all existing thermal satellite missions, which means that currently no satellite sensor can provide frequent and detailed surface temperature maps for cities. That is why Cure is applying a downscaling approach to retrieve land surface temperature of higher spatial resolution than the measurement by exploiting Copernicus Services products and optical satellite missions. In detail, Cure is using the surface cover information from several land monitoring service products, as for example the Urban Atlas and the imperviousness layers, with very high resolution imagery from the Copernicus contributing missions, as well as information from the Climate Change Service for the atmospheric correction of the thermal measurement. Intermediate products from the application 1 include, for example, detailed surface cover maps of 2-meter spatial resolution, such as the one you see here for the city of Berlin, and information on the change of the vegetation cover through time, as you see here the example for Berlin for 2019. The final Cure products are detailed surface temperature maps, which reveal information on the temperature of the individual surfaces. You see, for example, in this daytime product for Berlin, the level of detail emerging. This is the surface temperature in 100-meter spatial resolution for the end of May 2019 in midday, 11:30 local time, where the paved surfaces like the road network, the parking lots, and the airport runways present higher surface temperatures than the urban green spaces, reaching up to 37 degrees Celsius. Another example here for the nighttime land surface temperature in mid-April 2019, a couple of hours after the sunset. The slow release of heat in urban surfaces is evident in this surface temperature map, a phenomenon well known as the surface urban heat island. While surface temperature maps like this can directly provide quantitative information for the impact of planning interventions, as for example the application of cool materials in paved surfaces that would immediately reduce the surface temperature, in order to have a comprehensive overview of the city's heat load, we need the combination of all heat-related applications. Only these can provide complete information on the heat load for different times of the day and different seasons, including the past and future, not only for monitoring reasons, but for supporting mitigation and adaptation strategies to reduce heat.